For the next problem, we are told that we have a converging lens. We have an object that is placed 4 centimeters to the left of the lens, and it's 1 centimeter high. And the lens has a focal length of 8 centimeters. We're told that on the right side of the converging lens is placed a diverging lens. These are 6 centimeters apart. This is not to scale because, well, obviously this is smaller than this one. I just ran out of room. So this is 6 centimeters away. And this lens has a focal length of negative 16 centimeters. Then we're asked to find the position and the height of the final image. So we want the position of the final image, we want the height of the final image. We'll call these F for final. Okay, and then we are asked to describe it, right? As usual. So describe it by, is it inverted or is it upright? Is it real? Is it virtual? And if we do those things, we should be able to do pretty much whatever you need to do. I don't know. You can use mirrors, right? Okay. So first thing we need to do is find Q1, right? That's going to be for this side here. We know P, we know the distance, we know its height, we know the focal length. We can find the magnification here of this mirror, of this lens, and we can find the image distance. And so that image distance for this lens is actually going to be the object distance for this lens. So I'll show you what I mean. Using the formula that we have, P minus F. Recall this comes from 1 over F is equal to 1 over Q plus 1 over P. Say that comes from there. Okay. And so P is 4 centimeters. Focal length is 8 centimeters. These are things that we're told in the problem. Then we have 4 minus 8 centimeters. 32 over 4 negative centimeters is equal to negative 8 centimeters. Is that what I got? That's Q. So this is going to be the first image distance, right? Now we have M is equal to negative Q over P, which is also equal to H prime, which is going to be the image height over the height of the object. So that's going to be negative over negative 8 over 4. So that's 8 over 4. That's 2 is equal to H prime, the height of the image, over the height of the object, which is 1 centimeter. So height of the image is 2 centimeters. And that's in the first lens, by the way. The main thing we really needed from here was this. So Q1, the distance of the image. Okay. So we have the next focal length, F2, is equal to negative 16 centimeters. And we want the object distance, right? What is the object distance? Well, the object distance is going to be the image distance plus the distance of the second mirror from the first. So we have whatever the object distance was here. What was it? It actually ended up being 8 centimeters. So it's this distance from the first lens plus the distance from the second lens. So we take both of those, right? By the way, I know that the virtual, it's virtual, right? Because it's negative. The virtual image distance is going to be on this side of the lens because we have a table that tells us if it's a negative value and this is a converging lens, it's going to be over here in front, right? So we add this plus this, which is 8 plus 6. So that's going to end up being 14 centimeters. Red, that's fine. 14 centimeters. Okay, and then we want the next virtual distance. we'll call this Q final is equal to P2 times F2 over P2 minus F2, which is going to be 14 times 16. This is going to be negative over 14 minus negative 16. Let's just double check this. Yep, and this is going to give us a value. Remember, this is going to be in centimeters. This gives us a value of negative 7.47 centimeters. Okay, now we can find the magnification of the second part, and that's going to be negative Q2, well, or Q final, I called it, Q final over P2. That's equal to, this is going to be negative 7.47, that's positive, right, over 14. And so that gives us a value of 0.53 is your magnification of that particular lens. Now we wanted the height of the image from this lens, right? So we'll just take h prime over h is equal to, remember the last one, we found the height of the last image, and that became, it was the virtual image in the last one, but it became the object height, right? It became the object height for this lens, so it was 1 over 2 centimeters. That's what I'm trying to say. And our magnification was 0.53, so to find h prime, we just multiply 2 times 0.553, sorry, that's sloppy, 53, and that gives us a value of a height of 1.067 centimeters. Okay, and then we want the total magnification, which all we do is we multiply the two magnifications together, and again 0.53 times, it was 2 before, so that gives us a value of 1.067, or we'll say just 1.07 about, is the total magnification for this system. And for this last one it was less than 0, so that means that it was in front of the lens. And then we had magnification that's greater than 0, and so that means that it's an upright image. Also, since this was less than 0, it became virtual, right? So it was virtual, it was upright, and it was in front of the lens. It was in front of the second lens. I'm not sure if I made that clear. Okay, next problem. We're doing great. We got one more problem in this set. 57. An object 2 centimeters high is placed 40 centimeters in front of converging lens having a focal length of 30 centimeters. Focal length 30 centimeters. 0.02 meters, 0.4 meters, 0.3 meters. Okay, that's the first setup. And then a diverging lens having a focal length of negative 20. This is f2, negative 20 centimeters. Placed 110 centimeters to the right of the converging lens. So the object distance is going to be, what we're told, it's 110 centimeters to the right of the lens, plus whatever we find the image distance to be from the first scenario. Okay, because we have a system, we have to consider not just this lens but also the other one. Same as the last problem. Almost exactly the same. What we want is the final position for the image, and we want the magnification, final magnification. We want to know if we want to describe the image, right? So is it upright or inverted? Upright or inverted? And then we're asked to repeat all of this for if the second lens has a focal length of 20 centimeters. So we do it all, and then we can kind of jump in halfway and repeat the calculation with 20 centimeters. Okay, so let's get started. So let's just determine all the properties we can about the first system. So we want to find Q. Recall that it's P times F over P minus F. And we'll call this one Q1, right? So we have, what is it? 40 centimeters. 40 centimeters times 30 centimeters over P minus F, 40 minus 30 centimeters, right? So this gives us a value of about 1.2 meters, 120 centimeters. Okay, and then we use that in our magnification. So it's negative 120 over P, which was 40. Negative 3 is our magnification. So note that, well, let's do one more thing real quick before I say anything else. So then we want to find the height of this one, of this object, of the image, excuse me. We want to find the height of the image. We know that the height of the object is actually, we're given in the problem, it's 2 centimeters. Right, and we have h prime, and this is going to be equal to negative 3. So h prime is negative 6 centimeters. Okay, so note that we have a positive value for Q, we have a negative value for M. So these are going to tell us a couple things. This is just for the first lens also, by the way, so this is inverted. This is not the answer to the question that we're asked because we still need to do the second lens, but this would be inverted and this would be placed behind the lens. So that's important to know. This is behind the lens, the first lens. So did I draw this? No, I did not. So, but let's imagine we have one lens here, and we found, okay, so here's your object, here's your focal length, and now we have this image distance over here in the middle. So we're going to need to consider that when we take the total object distance for the next lens. Okay, so now let's consider that the focal length we're given is, what was it? The second focal length was negative 20 centimeters. Negative 20 centimeters. The object distance is going to be the distance between these two. Like, so we're given a total distance between the lenses. And then since, in the last scenario, this image distance was way over here, so we added them up. But now since this is like in the middle, we're going to take this distance minus this distance, right? So this is going to be minus P prime minus, what was it? It was 120 centimeters. Where P prime was 110 centimeters. So 110 centimeters minus 120 centimeters is equal to negative 10 centimeters. So that is our object distance for this particular lens. So now we need to find the image distance for this lens using that. Okay? Recall Pf over P minus F, negative 20 times negative 10 centimeters squared over negative 10 minus negative 20 centimeters. Just double check my work here. So this becomes positive and this becomes positive, so we have 200 centimeters, 200 over 10 centimeters. Right, so that's 20 centimeters. So the image distance is 20 centimeters, and it's positive. So QF is greater than 0. which tells us that it's behind the lens, and it's a real image, right? So now let's find magnification for this particular lens, and then we can find the total magnification. So we had negative 20 over negative 10. That's positive 2, which tells us since our m is greater than 0 for this lens, it's an upright image for this lens, right? That doesn't mean overall, because we still have to figure out m total is equal to m1 times m2. So these are magnification for the first lens times magnification for the second lens. So the final magnification would be positive 2 times, what was the other one? It was negative 3. Yep, negative 3. Which gives us negative 6, right? So that means that the final image is inverted, and it's 6 times larger than the object. Okay, so we found the image distance for the second lens for the final, and then we found the magnification for the second lens, and then we found the total magnification. We discovered that it's inverted. It's a real image, it's behind the lens, and it's 6 times larger. Now we want to repeat all of this for f equals positive 20, for f2 equals positive 20 centimeters. So the second lens has been changed. Okay, so Q final is going to equal PF over P minus F. That's going to be, what was it? Negative 10 times 20 over P, negative 10 minus 20, right? So that's going to give us a value of negative 200 over negative 30, which gives us a value of 20 over 3, which gives us a value of approximately 6.67 centimeters. It's positive value. If we know it's a real image, since it's positive, also we know it's behind the lens. Now M2 in this case, negative Q over P, is going to be, what do we have? Negative 6.67 over negative 10, which gives us a value of 0.67. This is a positive number, so M2 is greater than 0, which means that it's upright in the second lens, but the final image may not be. So let's just hold on there. All right, so now we have M total magnification, 0.67 times negative 3 is equal to negative 2. So M is less than 0. So the final image is inverted. It's 2 times larger. We know it's real, and it's behind the lens. Great job, everyone.